section of this course we're going to be applying radian measures. So the first way we're going to do that is by calculating arc length and area of sectors. So if we take a look, we have circle A and we have an arc NT on that circle. And if I measure the central angle, so angle TAN, I have a 26.34 degree angle right now. And we know that our entire circle is 360 degrees. So if I were to compare the central angle to the circle, that central angle is approximately 7% of the circle. Well, if I go ahead and I compare the length of that arc over the actual circumference of the circle, so if I compare the distance I would walk from N to T compared to the distance if I started at N and walked all the way around to the circle, we'll notice that that ratio is exactly the same. So those two ratios are proportional. So no matter how I move my central angle, okay, I'm at 20%, I'm at almost 50%. No matter how I move that, those two ratios stay proportional to one another. Alright, so the ratio of the arc length to the circumference is proportional to the ratio of the central angle over the entire circle. It's going to hold true when we look at the area of that sector and not just the length on the circle. So if we look at the area of sector CFB, it's 11.13 square centimeters compared to the area of the circle, which is approximately 89 square centimeters. So this area right now is about 12% of the circle. And as I increase my central angle, so right now I have 136.35 degree central angle, which is approximately 38% of 360 degrees, I notice that the area of the sector is also 38%. So our observation again is that the ratio of the area of the sector to the area of the circle is proportional to the ratio of the central angle measure over the entire circle. So with that being said, we can derive the formula for the arc length that we'll be using forward. So what we looked at through Geometer Sketchpad was that the arc length over the circumference is proportional to the central angle over the entire circle. So the arc length is what we're going to be trying to figure out, but we do know a formula for circumference. Okay, that would be 2 pi r, or pi times diameter. The central angle we can call theta, and we know the entire circle in radian measure is 2 pi. Okay, it's really important that you understand that every time we use the arc length and area of sector formulas, it does have to be in radian measure. So if I were to solve for arc length, I would need to multiply both sides by 2 pi r. So my 2 pi r ends up in my numerator with my theta. And then you can see I can cancel out my 2's and I can cancel out my pi's. So when I go ahead and cancel those out, I'm left with arc length is the radius times the central angle. Again, you need to remember that the angle has to be in radian measure. Okay, it's really important that you understand that. So we can derive the same way the formula for area of a sector. So we take our sector, this time it's over the area of a circle, which is pi r squared. Our central angle is again theta, and our entire circle in radian measure is 2 pi. By multiplying both sides by pi r squared, we have pi r squared theta over 2 pi. This time only our pi's cancel out, so our final formula, which should say area of a sector, so let's fix that, area of a sector, that formula would be 1/2 r squared theta. Okay. So our two formulas, again, are giving us our application for our radian measure, which we're going to be using going forward. So let's look at one example problem, and then there'll be an example problem that you need to do on your own, and we'll go over in class tomorrow. All right, so our job is to find the exact arc length and area of a sector with the given information. So we're given a 45-degree angle with a radius of 12 centimeters. So arc length is represented by the letter S, and S is equal to theta times R. Again, we have to remember we needed to first convert our 45 degrees into pi over 4. Okay, and from here all we have to do is reduce. So our arc length is equal to 3 pi centimeters. That would be exact. If I ask for approximate, you just need to put that in your calculator and round. Okay, don't forget your units. So area of a sector, area is 1/2 pi r squared. We square our 12, which is giving us 1/2 pi 144 centimeters squared, and then we reduce to get 72 pi centimeters squared. Again, if I ask for approximate, just put that in your calculator. So I need you to do this problem for tomorrow, and then we're going to do some more application problems.